So in this video we will do a lot of examples of limits that involve the following limit of sine of theta over theta. As theta goes to 0, this limit is 1. Okay, as we have shown in the previous video uploaded on my channel, the limit of theta goes to 0, theta over sine of theta is equal to 1, and we were able to prove that limit of cosine of theta minus 1 over theta as theta goes to 0 is equal to 0. Okay, so we will use all of these values, and we'll use some basic trigonometric identities such as sine square of theta plus cosine square of theta is equal to 1, tangent of theta is equal to sine of theta over cosine of theta, cotangent of theta is the reciprocal of tangent of theta, which means cosine of theta over sine of theta. Secant of theta is equal to the reciprocal of cosine of theta, and cosecant of theta is equal to the reciprocal of sine of theta. Okay, from now on I would expect that you know these definitions of cotangent, secant, and cosecant. Okay, so let's start with some easy examples. So evaluate the following limits. Okay, 1, limit as x goes to 0 of sine of 4x over x. Okay, so now always think of theta, right? When x goes to 0, this is my theta goes to 0, right? As x goes to 0. So theta is 4x, and I have to divide it by the same amount, by the same value, in order to be able to use this limit, because I want sine of theta over theta, sine of this angle over the same angle as the angle shrinks to 0. So what is my angle? It's 4x. Always first identify the angle. In order to get 4x, I simply multiply the denominator by 4, and in order to get the same value of the expression, I need to multiply the numerator by 4. Okay, so this is equal to the limit of 4 times sine of 4x over 4x as x goes to 0. Again, as I said, as x goes to 0, this theta here goes to 0, is divided by the same expression, sine of theta over theta as theta goes to 0, the whole thing goes to 1, and then I have limit of 4 times 1, that's equal to 4. Problem number 2 is the limit as x goes to 0 of sine squared of 4x divided by x squared. Now this is an easy problem. All I just wanted to make sure that you understand that when I say sine squared of theta, this means sine of theta times sine of theta, okay? Or in other words, sine squared of theta is not the same as sine of theta squared. Be careful, those are completely different, right? This is sine of theta times theta, okay? Always start with the direct substitution as we have done so far. Sine of 0 is 0, so 0 squared is 0, 0 in the numerator goes to 0, the denominator goes to 0, right? Now in order to make this a little bit slightly more visible for us, I have a limit of sine of 4x, times sine of 4x. That's what I said. What does it mean, sine squared of 4x? Sine of 4x times sine of 4x over, and of course x can be written as x times x. Okay, so if I want this ratio to go to 1 as the angle theta, and in our case that's 4x, goes to 0, I need to divide sine of 4x by 4x. So that means I multiply this x by 4. And now this limit, this ratio goes to 1. The same thing I can do it here, 4. And then I have sine of 4x over 4x as x goes to 0. That ratio approaches to 1. But now be careful, we have multiplied the denominator by a total of 4 squared, which is 16. And in order, we cannot just multiply the denominator simultaneously, we have to multiply this numerator by 16. So now I have 16 times 1 times 1, that's simply equal to 16. So we're just going to do one more example here of the same type. Limit as x goes to 0, sine squared of x over 3 over x squared. So one way to do this, at least for all of you who are doing this for the first time, write sine squared as sine of x over 3 times sine of x over 3. Right? Of course, always start with direct substitution. So 0 divided by 3 is 0, sine of 0 is 0, and 0 in the denominator. And here I have x squared is just x times x. Now, if I want this limit here to go to 1, to approach to 1, my theta in our case, in this particular case, this whole thing is theta, right? Theta is equal to x over 3, so I have to divide sine of theta by theta. So that means that I have to divide it, this guy here, I have to divide it by 3. And now as x goes to 0, the angle theta shrinks to 0 divided by theta, that approaches to 1. Obviously, I have to do the same thing for this guy. And this goes to 1. But now be careful, I have divided the denominator in total by 9. That means I have to multiply the numerator, I have to multiply the denominator by 9, because 9 divided by 3 is 3 divided by 3 is 1. So I have 1 over 9 times these two ratios that are approaching to 1 as x goes to 0. 1 over 9 times 1 times 1 is 1 over 9. If we have a limit, this is slightly more complicated problem. 1 minus cosine of x as x goes to 0. Okay, use direct substitution. Now cosine of 0, please be careful, cosine of 0 is 1. Okay, so cosine of 0 is 1. Under the square root I have 1 minus 1, which is 0, so 0 in the denominator, 0 in the numerator, I have 0 over 0. Okay, so how from here I'm going to get to something, some expression that I know how to solve. Okay, so as x goes to 0, in my mind I have the idea that sine of x over x as x goes to 0 actually goes to 1. And the question is how to get rid of this square root. Someone might think, well, why don't I just multiply this by this, because I want to get rid of the square root in the denominator, and it's one factor by itself. I can multiply top and bottom by the same expression, and then square root of 1 minus cosine of x times square root of 1 minus cosine of x will deal with the square root. But you can try that and you'll see that you're going to end up with something that then you have to again do what I'm about to do. So here I multiply this by square root of 1 plus cosine of x, square root of 1 plus cosine of x, and now you will see why. So this is equal to the limit as x goes to 0, x times square root of 1 plus cosine of x, square root of 1 minus cosine of x times 1 plus cosine of x. Okay, but this is difference of squares. So this is equal to the limit as x goes to 0, x times square root of 1 plus cosine of x over square root of difference of squares, that's 1 minus cosine squared of x. Okay, but now what did I say? The most important trigonometric identity is 1 is equal to cosine squared of x plus sine squared of x. Now if you bring cosine squared on this side of the equation, you get 1 minus cosine squared of x is equal to sine squared of x, which means that the expression under this root is simply square root of 1 minus cosine squared. 1 minus cosine squared is sine squared. And now I have limit of x times square root of 1 plus cosine of x over square root of sine squared is just sine of x. As x goes to 0, we know that x over sine of x as x goes to 0 also goes to 1. Now use direct substitution. You get square root of 1 plus cosine of 0. Cosine of 0 is 1, so that's 1 plus 1 is equal to 2. Okay. If you have the limit as x goes to 0 of 1 minus cosine of x over x, use direct substitution. 1 minus 1 is 0, divided by 0 is 0 over 0 limit, which we don't know how much it is. So what you can do is just factor negative in the numerator, so you have cosine of x minus 1 over x as x goes to 0 is equal to negative times the limit of cosine of x minus 1 over x as x goes to 0, and we proved this in the previous video that it's equal to 0. So this limit is 0 times negative 1 is equal to 0. Okay. This is problem 6. Limit as x goes to 0 of 1 minus cosine of x over x squared. Now be careful how you're going to think about this problem, because if you think in these terms, 1 minus cosine of x over x times x is equal to 1 minus cosine of x over x, these are the same. This is an identical expression, right? So this approaches to 0 and this approaches to 0. So again, I have 0 over 0, which means that I have to do something different, okay? So how am I going to get from 1 minus cosine x to some expression involving sine of x? Well, again, I'm going to remind you that 1 minus cosine squared of x is sine squared of x. And in order to get to this expression, I'm going to multiply the numerator by its conjugate. So that's difference of squares, 1 minus cosine squared of x over x squared, 1 plus cosine of x. 1 minus cosine squared of x is sine squared of x over x squared, 1 plus cosine x as x goes to 0. And if you cannot notice right away that this actually goes to 1, then take one extra step. That's sine of x times sine of x over times x, right, in the denominator, times 1 plus cosine of x. And this limit as x goes to 0, these two limits are approaching, these two ratios are approaching to 1. Use direct substitution and you get cosine of 0 is 1, so 1 plus 1 is equal to 2. Okay, in the next problem, we will use the trigonometric the definition of tangent of x. Tangent of x is sine of x over cosine of x. Okay, and the limit is tangent of x over x as x goes to 0. Now tangent of 0, you should know that it's 0, okay? But that comes from the fact by the definition of tangent, that sine of 0 over cosine of 0. Sine of 0 is 0, cosine of 0 is 1, 0 divided by 1 is 0. That means that if you use direct substitution, tangent of 0, as we just said, is 0, the denominator is 0. So I have a 0 over 0 limit, which means that I have to modify this somehow. So by the definition of tangent of x, this is sine of x over cosine of x over x as x goes to 0. Simplify this expression and you get sine of x over x times cosine of x. And now, hopefully, by now you can recognize that this ratio is going to approach to 1 as x goes to 0. Use direct substitution of what's left. 1 over 1 is equal to 1. Why do I have 1 in the denominator? Because cosine of 0 is 1. Okay, and let's say that we have limit as x goes to 0 of sine of 5x over cosine, over sine of 6x. Okay, very common mistake is here to cancel this somehow, and because that's impossible, I'm not even gonna guess how some students think that this is possible to be cancelled. So because it's impossible, here you just identify these angles, right? This, the first angle is, this is theta, and let's call this omega. Okay, and of course it's the same thing, is going to be sine of theta over theta. You can call the angle whatever you want. As the angle goes to 0, that goes to 1, and then of course sine of omega over omega. As omega goes to 0, that ratio of course is going to go to 1. So that means that I want to divide the numerator by this expression, by this angle, by 5x. So that's sine of 5x over 5x. If I just divided the numerator by 5x, I have to multiply it by 5x. And I follow the same logic for the denominator. Sine of 6x over 6x. If I divide the denominator by 6x, I have to multiply it by 6x. But now, as we said, as x goes to 0, this angle 5x shrinks to 0. Sine of theta over theta goes to 0 goes to 1. By the same logic, this one goes to 1. And now this limit here is very simple. Limit of 5x over 6x as x goes to 0. You cancel the one giving you 0 over 0. The answer is 5 over 6. And the last problem maybe is going to be the most difficult one, but it's not that tricky. Here you have to know the identity of sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b. And as a matter of fact, if you have a difference here, then the sign is going to change here. And the cosine of a plus b is equal to cosine of a cosine of b. If it's cosine of a plus b, then here I have minus sign, sine of a sine of b. And if I have difference between a and b, cosine of a minus b, then the sign changes here. Okay, so let's have this limit of tangent of theta minus 1 over theta minus pi over 4. And now be careful, theta approaches to pi over 4. as theta approaches to pi over 4, tangent of pi over 4 is equal to 1. So I have 1 minus 1 in the numerator, and which is 0, and pi over 4 minus pi over 4 in the denominator, which is 0. So I do get 0 over 0 limit, and I have to do something with it. But now, be careful. Look at this. Theta goes to pi over 4. I don't want to change that. I want in my mind to have something like this. Sine of theta, or x, let's say in this case, because that's how I'm going to change it, over x, to go to 1 when x goes to 0. This is what I want to use. Okay? So let's use the following substitution. Why don't I just say, let us rename, or let us name x to be equal to theta minus pi over 4. Okay? Then, as theta approaches to pi over 4, right, if I send this towards, and if theta goes to pi over 4, then pi over 4 minus pi over 4, x will go to 0, right? If I send x towards pi over 4, this difference will shrink to 0, so x will approach to 0. This allows me to rewrite this limit. Okay, so this whole thing now, I called it x. So in the denominator I have x. Then the question is, how much is theta, right? From here, if x is equal to theta minus pi over 4, then only theta is equal to x plus pi over 4. So I can rewrite tangent of x plus pi over 4 minus 1. And then, as I said, as theta goes to pi over 4, x will approach to 0. Okay? So now I got something closer to what I want right here. Now, as we have previously said, tangent of alpha, of any expression alpha, any angle alpha, is sine of alpha over cosine of alpha. So here I have limit as x goes to 0, sine of x plus pi over 4 over cosine of x plus pi over 4 minus 1 over x. Now if you bring this under common denominator and simplify the expression, and I would expect you to do that by yourself, you get sine of x plus pi over 4 minus cosine of x plus pi over 4 over x times cosine of x plus pi over 4. As x goes to 0, you get sine of pi over 4, which is square root of 2 over 2, minus cosine of 0 plus pi over 4, that's cosine of pi over 4, which is square root of 2 over 2, so the numerator goes to 0, and because of this factor x, the denominator also goes to 0. So in order to evaluate the numerator, to deal with the numerator, I'll use these two formulas. So this is equal to the limit as x goes to 0. Now this expression first, sine of x times cosine of pi over 4 plus cosine of x times sine of pi over 4 minus, now I use this formula here, cosine of x, cosine of pi over 4 plus, or you can do it like this and then minus here, sine of x, sine of pi over 4 over x times cosine of x minus pi over 4. Okay? Now here you should guys know that sine of pi over 4 is equal to cosine of pi over 4, and that's square root of 2 over 2. Okay, so this last line can be rewritten as limit as x goes to 0 of, so this is square root of 2 over 2, this is square root of 2 over 2, this is square root of 2 over 2, and this is square root of 2 over 2, right? So that's square root of 2 over 2 sine x plus square root of 2 over 2 cosine of x minus, I'm dropping the parentheses, square root of 2 over 2 cosine of x. Negative and negative becomes plus square root of 2 over 2 sine of x. In the denominator, this factor here waits us to be dealt with, so we don't do anything. Cosine of x minus pi over 4. But now, you can get rid of this, and square root of 2 over 2 sine of x plus square root of 2 over 2 sine of x is just square root of 2 sine of x over x times cosine of x minus pi over 4, right? 1/2 of anything plus another half of anything gives you that whole anything, right? And finally, as x goes to 0, this is the limit that we are working with this whole video. So you have square root of 2. Sorry, I made a mistake here. I invented this minus out of nowhere. So here it's plus cosine of x plus pi over 4, right? So here I changed the sign by mistake. Okay, so this is plus also. So here it's plus and here it's plus. So it's the limit of square root of 2 over cosine of x plus pi over 4. Now do a direct substitution. You get square root of 2 over cosine of pi over 4. As we said, cosine of pi over 2 is square root of 2 over 2. And this is simply equal to 2.